Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's presentation, we'll be looking at one of the important assumptions of linear regression. What is this assumption? One of the important assumptions that the linear regression makes is that the independent variables must be uncorrelated. I repeat, the independent variables must be uncorrelated. The problem is many times when we work on multiple linear regression, several variables will be related. When there is interrelationship between a couple of variables or interrelationship among several variables in the independent list, this leads to the problem of multicollinearity. Now, when we have the problem of multicollinearity in the data set and we go ahead with fitting a regression model, we will get fallacious results. What will happen if we build a regression model despite the problem of multicollinearity? There are at least three problems that you will encounter. First, the unstandardized coefficients will be not reliable. The coefficients will be unreliable. Standard errors will be very high. The confidence interval for these estimates will be very wide. And this leads to the problem of overfitting. Multicollinearity is one of the main reasons as to why there is the problem of overfitting. So in this video, we will explore how to detect the problem of multicollinearity. I repeat, how do we check the problem of multicollinearity? Does the data that we have suffer from this disease of multicollinearity? If we are able to detect the disease, then we will be able to propose the medication later appropriately. So without wasting too much time, let me go ahead and tell you how the problem of multicollinearity can be detected. As you can see, this is my SPSS screen. Let me click on the file menu. The very second option here is what is called as open. I'll choose the first item here, data. SPSS takes me to the folder which is called as English folder. There are several files here. I will be working on the file which is called as car sales. So this is the data set that I have. What is the sample size in this particular data set? 157. There are different manufacturers of car. You have different models of car like Integra, TL, CL, RL, so on and so forth. You have what is the sales value and different vehicle characteristics like resale value, what is the type, price, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, mileage per gallon. You also have the log sales here. The first problem here would be to identify the problem of multicollinearity. To do this, let me click on Analyze. In the Analyze menu, you have a whole lot of options. I will choose the option Regression and then choose the second item, Linear. It is asking me to specify the dependent as well as the independent list. Remember, linear regression is an example of supervised learning technique. When I say supervised learning technique, we have a dependent variable here. So we have seen sales is not normally distributed, and linear regression works best when the dependent variable follows normal distribution. So instead of working on the variable sales, what I will do is I will choose the variable log transform sales. I will push this in the dependent list. When it comes to vehicle characteristics like 4-year resale value, vehicle type, price, engine size, horsepower, wheelbase, width, length, curb weight, and fuel capacity, I can also go ahead and include mileage per gallon. These 10 variables will be my independent variables. I'm interested in estimating the coefficients. I'm also interested in finding out which of these variables influences the dependent variable. There are a whole lot of options here. I will click on the first option, statistics. The default option produces the coefficients as well as the model fit. I am interested in what is called as part and partial correlation. Please click on this option. You can also choose the option collinearity diagnostics. So here, the problem is to first of all detect whether there is multicollinearity in the data set or not. I repeat, our goal is to find out whether there is multicollinearity in the data set or not. And therefore, I will be choosing two options, part and partial correlations. And the second option is what is called as collinearity diagnostics. Both these options are present in the statistics tab. For this video, I will be ignoring some of the other options. Let me click on the option continue. And this is my settings. I've chosen log transform sales as the dependent variable because it gives me a better R square. And I've chosen 10 different variables in the independent list. I will go ahead and click on OK. The very first table tells me all the independent variables that I have entered, like fuel efficiency, 4-year resale value, length, so on and so forth. The second table gives me a description about the model summary table. And as you can see here, 0.426, this is the coefficient of determination value. It simply says that 42% of the variation in the dependent variable is explained by the set of independent variables that I have taken in the model. Is that significant? When you look at the p-value for in the ANOVA table, the p-value is 0.000, which is less than 0.05, indicating that the R square value is significant. Let me scroll down and show you the coefficients table. Now, we have already looked at what is the unstandardized coefficients as well as standardized coefficients. In case you're watching this video for the first time, I request you to watch my earlier video on multiple linear regression to make sense of some of these coefficient values. May I draw your attention to the significance level here? Now, when you look at the significance level here, this is the p-value. The p-value for many variables is bigger than 0.05. When you look at variables like horsepower or engine size, or for that matter, even price or length, curb weight, and fuel capacity, and also fuel efficiency, the significance level for each of these variables is bigger than 0.05. This means that there are several non-significant variables which have been included in the model. What does this imply? This implies that though these variables are not contributing, they're still in the model. That is one way of looking at it. But more than this, let's come to the very purpose of this video. The very purpose of this video is to impress upon you certain statistics, certain thumb rules, which we can use to detect multicollinearity problem. We want to detect multicollinearity problem. What helps us is basically what is called a zero-order correlation is being displayed. Correlation, that is partial correlation as well as part correlation, is displayed. Collinearity statistics, that is tolerance and VIF, is displayed here. How do we make sense of this barrage of numbers? To make sense of these barrage of numbers that we see, let me just show you an Excel sheet. This Excel sheet is very, very useful if you want to detect the problem of multicollinearity. Even before I explain some of these points, let me give you an example. There are certain thumb rules. Forget statistics for a moment. If you want to find out whether a person suffers from fever or not, what do? You may not be a doctor, you may not have a degree in MBBS. What you will do is you put a thermometer in his mouth and you notice the temperature. If the thermometer reading is greater than 100, you say you have high fever. So 100 becomes a thumb rule for you to decide whether the person suffers from high fever or not. Similarly, if you want to check whether a person is suffering from diabetes or not, 106 becomes a thumb rule. If a person has a diabetes level, if a sugar reading shows a value greater than 106, you can conclude that yes, there is high sugar level in a person. Similarly, When you want to check whether a person's BP level is normal or not, you look at the reading between 80 and 120. If the BP level is between 80 and 120, you go ahead and say, yes, the person is normal, or else you say that the person's BP level is abnormal, right? So whether it is fever, whether it is checking BP level, or for that matter, even when it comes to checking sugar level, there are different thumb rules. Based on these thumb rules, we evaluate whether or not a person has fever, whether or not a person has sugar, or whether or not a person's BP level is normal or not. The same way, to check whether there is the problem of collinearity, statistical experts have come up with thumb rules. And these thumb rules is what I will be speaking about in this particular video. Let's look at what are some of the thumb rules. You can look at least 6 different thumb rules. The first one being tolerance level. Tolerance level is one of the indicators of multicollinearity. There are other measures like VIF, or what is called as variance inflation factor. This metric can also be used to detect multicollinearity. The third metric that you can use is Eigenvalue. People also use Conditional Index. Sometimes people check the conditional number. And in many cases, people also look at partial and part correlation to detect the problem of multicollinearity in the data set. So any of these 6 measures can be used to check for multicollinearity. The question is, how do we look at each of these metrics? There are certain threshold values. For example, when you look at the tolerance level, if the tolerance level is below 0.25, I repeat, if the tolerance level is below 0.25, it indicates high multicollinearity. What happens when the tolerance level is below 0.25 is that the standard error of the regression coefficients will be inflated. Very, very important point. If the tolerance is below 0.25, please be careful, the data has multicollinearity. The second popular metric is what is called as VIF. VIF stands for variance inflation factor. If the VIF is above 4, it is again an indicator of high degree of multicollinearity. I will make a move on to the third metric, which is eigenvalue. If the eigenvalue is close to 0, it again indicates high degree of multicollinearity. What happens when the eigenvalue is close to 0? It simply will result in the following fact: small changes in the data values may lead to large changes in the estimates of the coefficients. I repeat, when the eigenvalue is close to 0, very, very small changes in the data values may lead to dramatic shift in the estimate of the coefficients. We don't want large changes in the estimates of the coefficients. We want the estimates to be stable. So please be careful, please be warned about eigenvalue being close to 0. Next 2 metrics are very interesting. You can look at conditional index. If the conditional index is bigger than 50, it indicates high multicollinearity. Conditional number is derived from the conditional index. So either you can look at one of these 2 metrics. If the conditional number is bigger than 30, that again indicates high degree of multicollinearity in the data set. This is the last of the metric, what is called as partial and part correlations. People do not use this often, but nevertheless, you can also use partial and part correlations to detect whether or not we have the problem of multicollinearity in the data set. How do you check for multicollinearity looking at partial and part correlation? What we do is we compare the value of the partial and the part correlation with 0 order correlation. When we compare the partial and part correlation with the 0 order correlation, and if we happen to see a sharp decrease in the values of partial and part correlation as compared to the 0 order correlation, we conclude that the variable is contributing to multicollinearity. So these are some of the ways in which we can check for the problem of multicollinearity. I have listed at least 6. Now you can look at VIF. This is the one measure which is popularly used to evaluate multicollinearity. A lot of the times people also use conditional index as a way of checking for multicollinearity. So the message that I would like to convey to my audience is twofold. If the VIF value is above 4, it means that the data has multicollinearity. If the VIF value exceeds 10, then there is serious, very, very serious problem of intercorrelation among the different variables in the data set. Similarly, if the conditional index is bigger than 15, you can again conclude that there is serious problem of multicollinearity. With this understanding, let me go back to the output of regression. As you can see, we have zero order correlation. We also have partial as well as part correlation. Let's examine some of these values. When you look at any of these values, there is a sharp decrease in the values. This is the zero order correlation for the variable width from 0.06. When you look at the zero order correlation and compare it with the partial and the part correlation, there is a sharp decrease of the partial and the part correlation. It reduces sharply. Whenever there's a sharp decrease in the partial and the part correlation, you can conclude that there are problems of multicollinearity. This is not just with the variable width or length. There are several variables in the data set wherein we see a sharp decrease in the partial and part correlation. This is one way to check for multicollinearity. Similarly, when you look at the VIF, when you look at the VIF, some of these variables have a VIF value of bigger than 4, 18 point something, definitely a problematic variable. 26.192, which means price is contributing to multicollinearity. The first variable resale value is contributing to multicollinearity. This variable 7 point, that corresponds to engine size. So the VIF corresponding to engine size of 7+. Horsepower, we have a VIF of greater than 11. For many of the variables, what we see is that the VIF value is greater than 4, indicating that there is serious problem of multicollinearity in this data set. All these variables, when you look at 4-year resale value, vehicle type, price, engine size, horsepower, the VIF value is greater than 4. As I said, VIF bigger than 4 is an indicator of multicollinearity. We spoke about the eigenvalue. If the eigenvalue is close to 0, it indicates the presence of multicollinearity. As you can see here, there are several eigenvalues which are close to 0, again indicating that the presence of multicollinearity is there in this data set. Conditional index. If you recall the discussion that we had, conditional index bigger than 15 is a problem. I can see at least 8 variables having a conditional index bigger than 15. You can see here numbers like 22, 34, 40, 50, 71, 79, 152, and 157. All these are great indicators of the problem of multicollinearity. We have conditional index. If I scroll to the extreme right side, we see different values, and they also report the variance proportions. In the earlier version of SPSS, they would also give the conditional number. I don't see the conditional number column present here. I'm using SPSS 26.0. If you refer to SPSS 15.0 or 16, along with conditional index, they would give you conditional number as well. But it looks like the conditional number metric is removed. Nevertheless, we can pay attention to 2 metrics. One is VIF bigger than 4 and conditional index greater than 15 as indicators of multicollinearity. So what is my conclusion from this observation? From this study, we can conclude that there is serious problem of multicollinearity in this data set. To summarize the discussion that we have had today, we have spoken about the problem of multicollinearity. Multicollinearity simply means that the independent variables have tremendously high values of relationship. There is very high degree of interrelationship among several independent variables, which lead to multicollinearity. You may ask me, so what? Multicollinearity leads to unstable estimates, large standard errors, wide confidence intervals. This is the impact of the problem of multicollinearity, and we don't trust the estimates when we have the problem of multicollinearity. Secondly, we have looked at different metrics which are indicators of multicollinearity. We looked at 6 different metrics. First, VIF bigger than 4, conditional index greater than 15, conditional index greater than 30, tolerance value less than 0.25, part and partial correlation dropping sharply. All these are indicators of multicollinearity. With this, I have come to the end of today's presentation. I request you to subscribe to my channel and hit the like button. Thank you very much for watching this video. Thank you and have a great day.